incompressible, differential, integral. Dito pag-usapan natin yung bulk modulus of elasticity, compressibility of gases, inviscid, viscous, at saka surface tension. So, ang common misunderstanding kapag sinabing fluid, liquid form lang siya, di ba? Tubig, yan. Fluids. Pero yung fluids, dalawa yan. Either liquid or gas form. So, yung compressible at saka incompressible, ang sample ng compressible, gases, di ba? So, pwede mo siya i-compress. Kaya niyang mag-compress into thin volume. Pero yung incompressible, yung like water, di mo yun mako-compress. Dito, learning objectives natin. Understand the basic properties of fluids, principles of viscosity, knowledge and calculation of capillary rise in tubes due to surface tension. So dito, yung ibang topic din, merong manometer. Hindi ko lang sure anong chapter yung may manometer. Pero kabisado nyo na yun sa term 1. So, dito tayo sa introduction. Property, meron tayong mga basic property na pag-aaralan dito. Yan, yung pressure, temperature, volume, at saka mass. Yung hindi naman masyadong common, yun yung mga viscosity, thermal conductivity, modulus, so on. So, I think pina-assignment kaya to. Maalala. So, meron to classification ng properties. So, yung properties, meron pa siyang classification. Yun yung intensive at saka extensive. So, para madaling matandaan, kapag intensive, independent yan sa mass. Ano yan? Yung condition niya, hindi nagdedepende sa mass, whether malaki yung mass mo o maliit, hindi yan nagbabago. Ano yan? Yung mga temperature, pressure, at saka density. Intensive properties ang tawag sa kanila. Independent sila sa mass. So, yung extensive naman, syempre, kabaligtaran ng intensive. Sino to? May mga nag-chat. Mamaya na ako mag-check ng attendance, no? After na lang. Kasi naka-record pa eh. Before siguro mag-end yung class na lang ako tawag dito. Mag-check na attendance. Sige. Yung nag-chat na na late, sige, i-unlock ko para makahabol yun. Mark Simon. Ay. Richard Simon. Si Kevin Manantan ba makakahabol pa?
Nagtatanong din po ma'am kung pwede pa po daw unlock.
Oh, sige. Ayan, in-unlock ko na. Sabihin mo mag-join na siya. Para makahabol naman. Sabihin mo mag-join na lang siya. In-unlock ko na yung meeting.
Sige po, thank you po.
So, yung extensive nga, yun yung kabaligtaran naman ng intensive, no? Kung yung intensive, independent siya sa mass, wala siyang pakialam. Dito naman, lahat ng ano niya, nagdedepend sa mass. Ano yun? Siyempre, yung total mass, volume, tsaka total momentum. Sabi dito, an easy way to determine whether a property is intensive or extensive, dinivide lang to ni Timbala. Basahin nyo na lang. Ito rin yung diniscuss ko kanina sa taas. Parang tinable lang niya. So, dito, at saka sa ibang subject mo, di ba minsan merong per unit mass na mga mga formula, no? So, yun, extensive properties. Ang tawag doon ay mga specific kasi mga per unit mass. Ba, mga kilogram per meter, meter per kilogram, baka naka per unit mass. So, fluid mechanics, so, study and motion of, ito, mga formula to, density at saka specific gravity. So, density, rho ang tawag dito, no? Dun sa parang letter P. Baka may hahabol pa sa meeting natin. In-unlock ko na, no? Pasabihan na lang yung mga hindi pa nakaka-join. Kaya ko siya pina-open sa inyo para nasusundan nyo yung dinidiscuss ko, no? Kasi nagkakaproblema tong desktop ko. Ayaw nyo mag-share ng screen. Or ayaw nyong nagkakaproblema yung Teams ko. Anyway, balik tayo dun. So, density, yun yung rho na tawag. Yan yung mass per unit volume. So, ano yan? M over V density. Sa SI, ano yan? Kilogram per cubic meter. Sa English, slugs per cubic feet. So, yung hindi pala nakasama dito. So, sa SI, yung force is in newtons, mass is in kilogram, length is in meter. So, tapos naman sa English units. So, yung force is in pounds or pound force. And then, yung mass mo is in slug. Your length is in feet or foot. So, dito, kapag yung density, mass over volume, sa SI, yan ay kilogram per cubic meter. Pero kapag English units, slug per cubic feet. Okay na yan, Mr. Manantan. Sige. Kung may habol pa, sige. Kaya na ako mag-set natin. Hindi ko pinapromote na malig kayo, ha? Nagbibigyan ko lang kayo ngayon. May valid reason naman. Next time, ilalak ko na. Merong nawala dahil sa bad. Pero namang recording. So, yan. So, yung reciprocal daw ng rho or density is specific volume. So, specific nga kasi nga meron siyang per unit mass, diba? Kilogram per cubic meter. Yan, specific volume. Reciprocal of density. 1 over rho. So, yung density, yun yung mag-determine kung ang isang bagay ay mag-float or magsisig sa tubig. Lagi na tinatanong yun, ano mas mabigat? Piso ba or yung barko? Ang sagot doon ay density ang nag-determine whether ang isang bagay ay mag-float or magsisink kapag it is more denser than water, it will sink. If it is lesser than water, it will float. So, ang density ng tubig ay 1,000 kilogram per cubic meter. So, in English, 62.4 pounds per cubic feet. Yun yung magdetermine kung either mag-float or mag-sink. Dito na to, basahin nyo na lang, no? Usually, water at 4 degrees Celsius, 1,000 kilogram per cubic meter. So, meron din tayong specific gravity, no? Ito, dimension ay unitless ang specific gravity. So, specific gravity is, para makuha mo yan, rho ng substance over rho ng tubig. Pwede rin gamitin yung specific weight ng fluid, substance mo over specific weight ng water. Lagi yan. Fix yan. Dimensionless quantity ang specific gravity. Next page 4. Ito, meron tayong table dito. Nakalagay yung specific gravity ng iba-ibang substance. Nasusundan nyo ba? Kung naka-open sa inyo, nasusundan nyo dapat.
Yes po.
Good. So dito, most common na ginagamit dito, I think yung water, seawater, and madalas ginagamit yan. Water at saka seawater. Tsaka rin ng air. So, sa problem, hindi ko na ibibigay yung specific gravity ng water, seawater, tsaka air. Pakimemorize. Madali lang naman. Yung water, 1.0. Seawater, 1.025. Yung air, 0.001204. Ito yung mga hindi ko na ibibigay na specify sa problem kapag nagpa-exam ako. Next. Ito yung mga may condition naman siya. Substance at 20 degrees Celsius at saka 1 atmospheric. And meron din dito ng mercury. Ito nga yung sinasabi ko kanina, yung nakanote na substance with specific gravity less than 1. If it is lesser, it would float. Less float. Kapag more denser, it will sink. The weight of a unit volume of substance is called specific weight or weight density. Yung specific weight, rho g. I suggest na igawa kayo ng sarili ng mga listahan ng formula, no? Kasi kung magre-rely lang kayo dito, medyo mabigat siya. Pero madali lang itong mga to. I-extract nyo lang yung mga useful formulas. Bago itong specific weight, rho g. G is the gravitational acceleration. Alam nyo naman na yan. Next is yung vapor pressure and cavitation. PSAT. Ito madalas natin magagamit sa mga PSAT. Refers to the temperature at which a pure substance changes phase at a given pressure. Saturation pressure, it will change. So, balik tayo. Saglit lang ah. Try ko siya i-share screen. Ayan, kita na ba yung screen?
Kita na po, ma'am. Yes po.
Ayan. So, tuloy natin, no? Dito tayo sa vapor pressure and cavitation. So, absolute pressure at standard 1 atmosphere is 1 atmospheric or 101.325 kilopascal. Yung gamit na gamit yan. Saturation temperature of water is 100. So, at 100 degrees Celsius, your corresponding pressure is 1 atmosphere or 101.325. Ito na yung figure na to, vapor and liquid phase ng pure substance. Ito, galing to sa book. Ito, may mga example dyan. So yung vapor bubbles, called cavitation bubbles also, form cavities in the liquid collapse as they are swept away from the low pressure regions, generating highly destructive, extremely high pressure waves. So, energy, sorry may siniset up akong para mamaya pag nag-solve tayo ng problems. Na-explain ko na siya na maayos. Energy can exist in numerous forms. Meron tayong thermal, mechanical, kinetic, potential, electrical. So, total energy is summation ng lahat ng energy involved. Ito yan. So, meron kang kinetic energy squared over 2. So, meron kayong potential. Kapag meron kang elevation, meron kang potential energy. Note na per unit mass itong mga to, no? Kasi wala ka namang given mass. Pero kapag meron kang mass, hindi ka naka-per unit mass basis. The analysis of systems that involve a fluid flow, ito yung combination ng enthalpy. So, formula enthalpy is U plus PV. Ito yung total energy ng simple compressible system, equation 8. Tapos, fluid flow. Ito, equation 9. I-ano nyo lang itong mga to, summary, no? Medyo ano lang siya dyan. Pero madali lang yung mga yan. Explanation lang itong mga to. Pero ito yung mga formulas na gagamitin. So, internal energy is CV delta T. Pag enthalpy, CP delta T. Tandaan nyo lang to, gamit na gamit tong formula na to. And then, so, coefficient of compressibility. Dito papasok yung bulk modulus of elasticity tsaka yung coefficient of volume expansion. Ito nga yung sinasabi ko kanina na fluids like solids compress when they are applied pressure. So, kapag, say, you have a jar and then, or piston na lang, kaya mo i-compress yung gas eh. Kaya mo i-push yung piston pababa. Diba? Pero kapag liquid yung nasa loob, hindi mo mapupush ang liquid. Hindi mo siya ma-compress. Fluids act like elastic solids with respect to pressure. Ito yung coefficient of compressibility, also called as bulk modulus of compressibility. Ito yung E. E is delta P negative delta P over delta V over V. Change ng pressure over change ng volume over volume. Ito naman yung formula ng isothermal compressibility. Speed of sound and Mach number. More mga formulas to. Speed of sound or the sonic speed is defined as the speed at which an infinitesimally small pressure wave travels through a medium. So C is equal to square root of kRt. And yung formula ng Mach number. Ay, ano pala to? Sonic speed. Ito yung mag-determine kung supersonic, subsonic. I think nandito rin yun eh. Mamaya sa baba. Yung Mach number naman, V over C. Actual speed ng fluid over yung speed ng same fluid. Ayan. Ito yung fluid flow. Sir James, the flow is called sonic when your Mach number is 1. Ito, memorize nyo to kasi madalas sa mga exam. Determine if it is sonic, subsonic, supersonic. So yung sonic, yung Mach number mo is 1. Subsonic is less than 1. So yung supersonic, Mach number mo is greater than 1. Itong mga hypersonic at transonic hindi masyado. More on sonic, sub, at saka super. Pero lumalabas din naman. So, viscosity. Viscosity, resistance to fluid is called viscosity. Viscosity is due to the internal friction force that develops between different layers of fluids. Ito yan. Say you have a water. Wait lang ha. I-share ko na lang ulit. And ayaw ng tablet ko. Sige, dito na lang muna tayo. Fluids for which the rate of deformation is linearly proportional to the shear stress are called Newtonian fluids. Say, meron ka, dito sa behavior ng ano. Say you have a water and then meron kang plate. Meron kang plate yan. So, meron yung shear stress, no? So, sabi niya, ang Newtonian fluids daw behave in linear motion. So here, U is a function. Ano pang ginamit dito? Y is a function of L. So, ano yung mga example ng mga Newtonian fluids that behave in a linear motion? So, meron kang water. I think, ano pa ba yung isa? Gas yata. Ito. Yan pala. Water, air, gasoline, air, and oils. So, Newtonian fluids, they behave in linear motion. Ano yung mga non-Newtonian naman? Meron ka dyan. Sample is, ito yung mga nagbibehave. Paint. Non-Newtonian yan, hindi yan linear. So, kapag kumuha ka ng paint, gamit yung brush, and then, ipapahid mo yun sa wall, hindi yan matatanggal. No? And then, example din is honey. Honey is more viscous than water. No? So, kapag binuhos mo yung water, mabilis yung flow niya. And then, kapag honey naman, mabagal. So, more viscous yung honey than water. More viscous yung oil than water. But more viscous yung honey kesa sa oil. Ito. Sabi niya, viscosity daw, ano lang yan shear stress over velocity gradient. Ito yung velocity gradient mo, no? du over dy. Ito yung viscosity mo, yung mu d. Viscosity is mu. So, isolate mo yan. Ang formula ng viscosity is mu over velocity gradient. Mu is shear stress over velocity gradient. Isolate mo to. Ito, bababa doon. Yung formula ng viscosity. Viscosity pala is also absolute viscosity or dynamic viscosity kapag hindi nakalagay sa problem. Kasi meron pang kinematic viscosity. Kapag nakalagay sa problem ang viscosity, take nyo yan as absolute or dynamic viscosity. Yun yung default niya. Next, shear force. Siyempre, shear is force over area lang yan. Force over area. Ito, shear stress is force over area. Yung kinematic viscosity naman, ito yung other ng viscosity. This is absolute viscosity or dynamic viscosity over raw. Over density. Kasi mas kabisado ko hindi nagamit yung raw. So, ayan ang formula ng kinematic viscosity. So, meron lang dalawang formula dito. Yung absolute or dynamic viscosity, that is mu, shear stress over velocity gradient. Ano yan? Yung mu is equal to tau over du dy. Surface tension and capillary effect. Ito, dalawa lang yung kakabisaduhin dito itong soap bubble at saka liquid bubble. Meron din mga dito, table. So, Hindi nyo naman i-memorize yan. I-given naman yan sa mga problem. O kung wala man, i-provide ko na lang. May certain condition yan eh. So, air at 1 atmosphere and 20 degrees Celsius. Biliary effect, meron tayong surface tension, meron din capillary effect. Meron kang container, and then nagpasok ka ng tube, inverted tube, no? Say inverted tube yan. So yung water, magpo-produce ng ganitong effect. Letter U yung sa taas niya. Kapag naman sa mercury, inverted U yung ipoproduce ng effect sa tube. Sabi niya dito, rise or fall of a liquid in a small diameter tube inserted into the liquid. So meron kang container and then meron kang pirasong tube. Ito yung magiging behavior ng fluids mo in terms of water and mercury. So meron ditong formula para makuha mo yung height ng rise is 4. Ayan. Specific weight and sorry, medyo ang bagal ng internet namin. Hindi ko alam bakit. Tagal bago ako naka-join dito sa laptop ko. Ayan. Pinapakita lang dito yung contact angle, no, ng water at saka ng mercury. Pero ito rin yan. So, yung dito sa taas, more on extra explanation. Pero meron din siyang summary dito sa baba. Dito, mas madali. Nakasummarize na lahat ng mga discuss. So, ano tayo? Summary, kapag yung property is dalawa, intensive at saka extensive. Kapag intensive, independent yan sa mass. Kapag extensive, dependent sa mass. Ano yung mga independent sa mass? Yan yung pressure, temperature. So, dito may mga formula. Common used properties of fluids. You have a mass, amount of matter given in a body. So, kapag sinabing weight, hindi pa rin yung mass mo, no? Magkaiba yung weight sa mass. So, yung mass is kilogram mass or pound mass. Kapag weight, pwede yung Newton. Newton is weight also. Or pound force. Kaya pina-assignment ko sa inyo yung mga kaibahan ng kilogram force sa kilogram mass or pound force sa pound mass. Over G, M is W over G. Weight, given yan. Minsan hindi, minsan mass na kaagad, no? And then yung G is 9.81 meter per second squared or 32.2 feet per second squared. Gravitational acceleration. Next is density. Density is mass per unit volume. Rho ang tawag. Dito mass, pwede siyang kilogram mass or pound mass or slug. Nabanggit ko kanina. Kapag kasi pound force, force yun. Kapag pound lang nakalagay, force yun. It's either kilogram or slug. So in volume, meter cube or feet cube. Specific volume is kabaligtaran lang nito, 1 over rho or V over M. Careful lang kayo dito sa mga units na. More on unit analysis to eh. Minsan kahit hindi mo alam yung formula, you can derive or unit analysis mo. Specific weight. Specific weight is the weight per unit volume. So, weight per unit volume. Ang unit nito, Newton per cubic meter or pound per cubic foot. Pound force. Yung pound mass also slug din yun. Specific gravity na banggit ko na kanina yan, or relative density rin ng tao. So yun. Rho ng fluid mo over rho ng standard substance, in this case, water. Ano yun? 1,000 kilogram per cubic meter or 62.4 pound per cubic foot. Yan. Ito, bulk modulus. Dito na pala lahat yung mga mga useful formulas na magagamit natin in solving problem. Ito yung bulk modulus. Saglit lang Stop ko muna yung sharing. Sige, kung naka-open naman sa inyo yan. Kung matapos natin yung mga example mamaya, quiz siguro kayo ng Tuesday. Announce ko na lang mamaya kung matapos natin yung problems. Dito pala sa module, ito rin kasi yung gamit ng kabilang prof, kabilang section. Balik ko lang yung screen. Ayan. The bulk modulus of elasticity is E. This is the change in pressure over the negative change in volume and the original volume mo. Pwede din yung rho. Delta P over rho. Negative yung sa baba Ano na siya na yan. Next is yung dynamic viscosity or absolute viscosity. Yung kapag sinabi yung viscosity lang, assume it is dynamic. By default, it is dynamic viscosity. So yan, sabi ko sa inyo, yung shear stress over velocity gradient. dV over dy. A perfect fluid has no viscosity and is incompressible. So, impossible yun. Minsan sinasabi nila ng zero viscosity. Meron pa rin yun, pero negligible na nga lang. Pero walang perfect fluid. lahat ay may viscosity or resistance to flow. Viscosity is resistance to flow lang naman eh. Kinematic viscosity is dynamic viscosity over rho. So, surface tension, property which exists due to the cohesion between the molecules at the surface of a liquid. So, dito meron kang bubble at saka liquid. Soap bubble at saka liquid bubble. Surface tension is PR over 4 or PR over 2. So, yung P pala, meron ka pang pressure gauge inside the bubble. Tsaka yung radius ng bubble. Note nyo lang ha na yung radius dapat naka-mm. Kapag SI, kapag naka-English inches. Capillary, mayroong adhesive, tsaka cohesive. Ito yung sa ano kanina, yung naka-tube. So, define lang natin, no? Adhesion is the attractive force between molecules of different substance. Cohesion, same substance naman. Ito pala different substance yung adhesion. So, cohesion, same substance. Meniscus yung tawag dun sa na-form na curve, no? So, sabi ko nga kapag water, letter U yung na-form. And kapag mercury naman, inverted U. Ito yung angle niya, this is greater than 90. Less than. And then sa mercury naman is greater than 90. So height, kapag papako yung height nung minsan height ng rice to eh, o height ng capillary rise or depression. Rise kapag positive, depression yung tapos. Ito yung formula na. Sige, sample problems tayo para mas madali. Ito, madali lang yung mga problem eh. Madali lang tong properties of fluids. So, ganyan kahirap. Nung kami nga, direct pang problem solving na kaagad eh. Wala yung mga definition ng mga terms at saka concepts. Number 1, determine the density and specific gravity and mass of the air in room whose dimensions are 4 by 5 by 6 at 125 degrees Celsius. So, isolate mo yung mga given. So, meron ka daw volume ng room, 4 by 5 by 6. Meron kang working substance na air ang nagsisirculate sa room. Wala kang problema yan. So, meron kang operating pressure na 100 and temperature na 25. Calculating the density using the ideal gas equation. Diba, ang ideal gas equation is PV MRT. Pero yung rho is mass over volume. Diba? So, yung mass over volume is equal to rho. So, magiging pressure is equal to rho RT. Yung PV MRT, yung M over V, magiging rho. So, pressure is rho RT. So, yung gas constant ng air, 0.287 kilojoule per kilogram Kelvin. So, ano na lang dyan na maging aware kayo sa mga units na ginagamit. Yung R. Substitute lang. Sorry sinisipon ako eh. So, yung substitute mo lang, pinapakuha niya, diba, yung density. Density is rho. So, isolate mo lang yung rho. Pressure over RT. direct substitution. So, yung naka-Celsius, gawin mo Kelvin para cancel Kelvin. Cancel. Kilojoules is kilonewton meter. Cancel yan, kilonewton. So, nitira kilogram per cubic meter. Specific gravity, di ba? Specific gravity is rho over rho ng water. SG mo is 0.00117. Unitless yan ha. Unitless ang specific gravity. Pwede mo rin gamitin dito specific gravity is specific weight ng fluid over specific weight ng water. The specific weight naman ng water at 4 degrees and or 39 degree Fahrenheit, 4 degrees Celsius or 39 degree Fahrenheit is 9.81 kilonewton per cubic meter. Dito pala, 1,000 diba sa SI. Sa English naman yan ay 62.4 pounds per cubic feet. Calculating the volume. So, volume ka ng mass ng air. Filled with air, sabi niya, diba? So, yan yung volume mo. And, rho is mv. Diba? Pinapako niya yung mass. So, meron kang rho, meron kang volume, ako kang yung mass. 140 kilograms. Direct substitute lang yan. Ito yung common example sa fluid mechanics. Reservoir of glycerin has a mass of 1,200 kilograms and a volume of 0.952 cubic meters. Find the glycerin's weight, mass density, specific weight, and specific gravity. So, isolate mo muna yung given mo. Meron kang mass, saka volume. Anong hinahanap? Find daw the weight. Weight is also force, di ba? Kasi nga naka-Newton. Force is weight or equals to mass times the gravitational acceleration due to gravity, 9.80. So yung weight, Newton yan, no? Hindi siya man pound force. So, ayan sagot. 11.77 kilonewtons. Meron ba kayong mga calcu? I hope meron kayong mga calcu na kasi ako kinakalcu ko pa rin kasi minsan baka magkamali, no? Hindi naman din ako perfect. Kakamali din. So, dapat meron din kayong mga calculator. So, meron ka ng rho. Meron ka ng mass. Meron ka ng volume. Pwede mo kunin yung rho. Actually, ito yung pinakauna mong pwedeng gawin. So, meron ka mass, meron kang volume. Rho is m over v or density. Density is mass over volume. Ito yung density mo. Specific weight. Specific weight. Specific weight ng glycerin is weight over volume. Specific weight. Specific weight is weight over volume. Ayan, substitute mo lang. Meron kang specific weight. Specific weight is 12.36 kilonewton per cubic meter. 77 times 0.952. Meron So, specific gravity. Specific gravity is specific gravity ng glycerin over specific gravity ng water. So, sabi ko kanina, pwede siyang rho ng water, fluid mo, or specific weight. Kapag ginamitan mo naman yan ng rho, so dito ba ang gamit natin specific weight or gamma? 12.36 over 9.81. Pero pwede mo rin gamitin itong rho. Rho ng fluid mo, in this case glycerin, over rho ng water. Na over 1,000. 1261 over 1,000. Sabi dito, in a water distribution system, the temperature of water observed to be as high as 30 degrees Celsius. Determine the minimum pressure allowed in the system to avoid cavitation. So, dito merong table. sabi niya dito, ito ano to eh. More on pagtingin ng sa table. Ito lang, PSAT, kunin mo lang yung temperature mo 30 tapos may corresponding saturation temperature ka na. Ay, saturation pressure. To avoid cavitation. Ano? Sabi niya, taking the coefficient of compressibility of water to be 7 times 10 raised to 5 pounds per square inch. Determine the pressure increase required to reduce the volume of water by 1% and 2%. So, equation 11, coefficient of compressibility. So, coefficient of compressibility is also known as bulk modulus or yung E. So, E, rearrange mo lang yan kasi meron kang E. Given yung E eh. Substitute mo lang yan. Sabi niya, volume of decrease ng 1%. Sabihin, yung delta V over V is 1%, 0.01. So, dito pinapakita lang niya kung ano yung behavior ng pressure mo kapag decrease or increase ka ng volume. Direct substitution lang. Siyempre, nag-double yan. Next, number 5. It is observed that the density of an ideal gas is increased by 10% when compressed isothermally from 10 atmosphere to 11 atmosphere. Determine the percent increase in density of the gas if it is compressed isothermally from 1,000 atmosphere to 1,001 atmosphere. Atmospheric pressure. Percent increase, pwede mo gamitin yung bulk modulus elasticity. Kasi meron kang dalawang operating pressure, delta P, 1,000, 1,001. Tandaan nyo lang itong equation 11 na bulk modulus of elasticity. Ayan. Direct substitution. So, meron kang 2 operating pressure, delta P, pag dinerivative mo yan, di ba, P2 minus P1 over P1. 10%. At 1,000 atmosphere, ito naman siya. Ito lang. Madali lang, no? Madali lang yung properties of fluids. More mga direct substitution lang. Dito kasi mapapamiliarize lang kayo sa mga unit. Density, specific rate, specific gravity. Yun lang naman yung objective nitong module ko. Air enters a diffuser shown below with the speed of, meron kaya dito. Wala na yung hindi na sinama yung image. Air enters a diffuser shown below within a speed of 200. Determine the following: speed of sound and Mach number. So, meron kang formula ng speed of sound, square root of KRT. So, gas constant ng air, and yung K, etong K gamit din to sa air, no? K ng air is 1.4. Wala kailangan ibigay yan sa problem. Ang K ng air is 1.4. Tsaka R na air. So, meron ka ng K, meron kang R, meron ka rin temperature. Substitute mo lang yan, makuha mo yung speed of sound. Speed of sound is C. So, meron ka ng speed of sound, pwede mo na kung yung Mach number. Mach number is velocity over speed ng sound. So, dito, Mach number is less than 1. So, subsonic na. Subsonic. The flow at the infuser inlet is subsonic. Next is viscosity. Hindi tayo matapos na pala mag-time. So, viscosity. If the viscosity of water at 68 degree Fahrenheit is, nakalimutan ko pala i-discuss yung poise, no? So, for dynamic viscosity, 1 poise is 1 dyne seconds per centimeter square. 1 dyne second per centimeter square. Poise yun. Poise. Compute its absolute viscosity. So, absolute viscosity, viscosity mu. If the specific gravity at 68 degree Fahrenheit is 0.998, compute its kinematic viscosity. So, dito, pinapakuha niya yung dynamic viscosity at kinematic viscosity. So, convert muna natin yung viscosity ng water at 68 pounds second per foot squared. So, sa poise nga, it is dyne second per cm square. 1 poise is ito. Dito nag-ano lang siya eh, convert mo na. So, 1 pound is 444,800 dynes. Paki-memorize nyo yung conversion na yan. Para mag-cancel yung dyne cancel, poise cancel. Diba? CM cancel. Ito na yung sagot mo. Ito lang yung sagot dyan eh. Pounds second per foot square. Yan yung unit ng viscosity. Viscosity is pound second per foot square. Pound force. Kapag ano naman yan, Newton second per meter square. Calculating kinematic viscosity. Kinematic viscosity is dynamic viscosity over rho. But rho is specific weight over G. Diba? Rho is specific weight over G. Pag minanipulate nyo yan, pag nag-unit analysis kayo, parehas lang. Hindi ko na maipakita kasi ayaw mag-work nitong tablet ko. Ayan. Substitute nyo lang para makuha yung kinematic viscosity. So, pag meron ka ng dynamic viscosity, makuha mo na yung kinematic viscosity. Ito. Matapos pala natin, no? 25 na. So, hindi na mag-check na attendance. Kunin ko na yung attendance report mamaya pagkatapos ng meeting. Next meeting na tayo kasi hindi ako kaagad nakapag-in kanina eh. So, consider a 0.15 mm diameter air bubble in a liquid. Determine the pressure difference between the inside and outside of the air bubble. If the surface tension of the air-liquid interface is meron kang dalawang condition. Sabi niya, air bubble, di ba meron tayong air bubble at saka soap bubble. So, air bubble over 2. So, soap bubble over 4. Tama ba? So, rearrange mo lang yan, manipulate mo yung equation, direct sum. So, R is radius, no? Radius. So, meron ka ng pressure. So, gamitin mo yung surface tension na 0.08 at 0.12 para makuha yung dalawang pressure. Ganun lang naman. Direct sub pa. Alam mo yung formula? Ito naman capillary. A 1.2 mm diameter tube is inserted into an unknown liquid whose density is 960. So, dito meron kang given density na hindi mo pwedeng gamitin yung density ng water kasi nga unknown liquid daw. It is observed that the liquid rises 5 mm in the tube, making a contact angle at 15 degrees. Determine the surface tension of the liquid. So, meron kang H na 5 mm. Sir, ang pinapahanap dito is surface tension, no? So, meron kang height, meron kang rho, meron pa rin gravitational acceleration, meron ka rin diameter. Sabi na dito, 1.2 mm diameter. And then, 4 cosine yung angle, contact angle. So, unit analysis na lang ang ano dito, ikabisado nyo. So, 1 Newton is 1 kilogram meter per second square. Dapat ang sagot is Newton per meter. Ito, wala naman na i-convert dito. Pero pinakita lang niya dito na 1 Newton is 1 kilogram meter per second square. So, ayun. Ito mga exercises, hindi ko naman nire-require na sagutan at isend nyo sa akin yung sagot. Hindi naman siya assignment. Practice solving lang sa inyo. May naka-open ba ng ano? So, sige, end ko na siguro yung discussion dito. Oras na rin kasi. So, next meeting,